All right, so we're down in the last characteristic of our function, and that is the interval of increase and decrease. And so I would like to discuss a little bit on interval, and that basically means the set of numbers within the same property. So when we talk about this interval, we actually refer to the values of x, wherein the y's have the same type of property. And these properties we're talking about are is whether the slope is an increase or decrease. All right, so let's look at this graph on the first graph. This is not really a quadratic graph. This is a cubic graph, but I thought it would be um, a good example to show increasing and decreasing. Okay, so let's when we read a graph, we normally start from left to right. We go from left to right. So position yourself here. Well, let's have this end right here. If the end, if you imagine the end starting from this point, going up, going up, going up, okay, and of course he keeps on going up until he reaches the top, okay, which is the maximum. So that's your maximum. It will start keep on going up. So every time it goes up, this is what you call your increasing interval. Okay, so this is increasing. And once you reach the top, of course, there's nowhere else to go higher but to start going down. So you start going down all the way to the lowest point, which is your minimum. That's your minimum point. Okay, so from this maximum point all the way to the minimum point, the action there is that you're like going down the hill, the aside of a mountain. So this is your decreasing part. Okay, now once you've reached the lowest point and there's somewhere else to climb, so you still go up, and so this part here is also increasing. So therefore you have two parts that are increasing from here to here, and from this minimum point all the way there. Okay, and we really are just interested with the interval, so meaning what are the x values of the starting point to the highest to the point to the highest point, and another starting point to the highest point. We just want the x of those. Okay, so what is the x coordinate of this? Well, this is an arrow, right? So that means it goes all the way back to negative infinity. Okay, so that's your point right there. And now, and it goes all the way down to negative infinity as well. So it's not really right to say it, but you may want to think of this as the coordinate of this is negative infinity to positive infinity, just for reference for now. And this point here, you have some sort of coordinates here, but your x is negative 3. And for some value of y, let me just call that y, we don't really know what that y is. We are really just interested with the x. So we're interested with this and that. Okay, so the interval of increase from this point to that point is, okay, this is your increase right here. Starts from negative infinity, this, all the way to negative 3. Okay, and please take note how I write this notation. I have parentheses for negative infinity, as negative infinity is not really an actual number, it's a concept. Now, I have a bracket next to negative 3 because negative 3 is part of the solution and it's an actual number, all right? So this is one part of the increasing part. And so we know that there's another increasing interval, which is this. And so I will look for the coordinates of this. The coordinate of this point is basically that's 1 and some point of y. Let's put that negative y. I don't know what that number is, but there's a number that represents that. I'm really just interested with the y, x anyway, so that's fine. Now for this point has 4 all the way to a certain number of y, right? Okay, so therefore the interval of increase from this to that is from 1 to 4, all right? So that's 1 to 4, and both of them will have brackets next to it, next to those numbers, because they are all both part of the solution. And I'll put a u in here. That means union. So this interval plus union means plus this interval are the intervals of this graph that are increasing. Okay, now for the decreasing part, okay, for the decreasing part, once you reach the top, you go down all the way to the bottom. Okay, so that's the decreasing part because like you're climbing down the hill. Okay, so basically your interval here is from -3 all the way to your x component of this point is 1, right? And both of that will be bracket, okay, unless you see an open circle. All right. Okay, so now let's move on to the second graph right here. Okay, so this is more like what we'll be dealing with. This is a quadratic graph, and the thing is, this is actually easier. These two are easier because you only have one increasing option, one increasing interval, and one decreasing interval. Like here, you have to add two or more, but this is a great example. All right, so first thing we need to locate is the maximum of the or the minimum. So for this graph, we have a maximum at point 0, comma 3. That's your maximum. And this one here, your coordinate here is -infinity all the way to why is this 0? This cannot be 0. It should be -infinity to -infinity. All right, and this one here is +infinity. Oh, these are okay. Those are not coordinates. Oops, I'm sorry. Okay, those are not coordinates. Okay, so let's concentrate on this graph right here. Okay. All right, so this graph it goes all -infinity to -infinity, while this graph also, this end, I mean, goes to positive infinity and, okay, and -infinity down, right, okay. All right, so where is the increasing part? As you can see, this is, if you position yourself here and starts climbing all the way to the top of the hill, so this is the increasing part because you're going up, okay, going up from left to right. So let's put the increasing. So it starts from -infinity right here. So that will be a parenthesis -infinity all the way to this point, and the x value of this point is 0. I put a 0 there and a bracket. Okay. Now your decreasing part from the top of the hill all the way down. So the top of the hill has an x coordinate of 0. Starts from 0. It's a bracket all the way to positive infinity. Okay, so that was those numbers are for. Okay. Okay, so this is, if you notice, this is a this opens downwards. Now on our third example, this opens upward. Okay, so this opens upward. Let's break this one down. This goes all the way to -infinity and all the way up, positive infinity. This one right here, all the way to the right, positive infinity, and up, positive infinity. And then we have this point, which is your minimum. So basically the first thing you need to do is look at your minimum or maximum. In this graph, we have a minimum, and your coordinates are 0, 0. Okay. All right, let's move on to increasing. Well, our increasing, well, this, if you start from left to right, from here to here, you're not really increasing because you're going down. But from here to here, you're going up. So you increase from this point all the way there. Okay, this point has an x coordinate of 0. So it starts from 0 all the way to positive infinity. And that will be a parenthesis. Now your decreasing part, from here to here, it starts from -infinity, all the way to this point, which is 0. All right, so why don't you try some of these exercises? Your packet, it should look something like this. You could try this and the succeeding parts. Okay, so in the next few pages, you would see that I have asked you to answer all the rest of the key characteristics, and I expect you to be able to remember all of these. Eventually, we will not be using notes when we start taking tests, as some of you are not really taking advantage of that. So make sure we remember all of that. All right.